Very good morning, my dear students. Let's continue the chapter called Motion in a Straight Line. Okay, so the name of the chapter, what we are continuing is Motion in a Straight Line. In this, we are still discussing the topic called motion under gravity. Alright. So today we are going to finish motion under gravity concept, and the next session we are going to finish the chapter. After finishing the chapter, I will be providing you 45 questions based on motion in a straight line chapter. That will be the assignment for you other than your daily assignments and exams. Understand? So, I would like to continue the applications of motion under gravity. Let's look at this application here. This is the commonly asked question in the NEET exam. So this is the ground. Carefully see. So there's the ground here. There is a tower of height h. So what is the tower of the height? H. From this top of the tower, there is a small body which is thrown up with some initial velocity u. Okay. So what I am writing, capital H is height of the tower. Each and every physical quantity is important here. So H is height of the tower. Then u is initial velocity of the body. Let's see. What happens here? Vertically projected body. So G is acceleration due to gravity. In this vertically projected body case, what happens, you're very well aware about this. The body will goes up, and at this particular point, the final velocity of the body will be 0. What happens here? So that's a point called maximum height from here to here. And the body will not stay at that position. It will start coming back. So the body will be started coming back. You can see carefully here. Carefully see. Now, if you see the point here, and with what velocity you throw the body up, with the same velocity, the body will start coming down here. Okay. In this case, T is time taken by the body to reach the ground. What is that? Time taken by the body to reach the ground, my dear students. Now, let us apply the formula called S is equal to ut plus half at square, my dear children here. What is S here? S is displacement. S is what? Displacement. It is not the distance traveled. Till now we have discussed the cases where the body is moving in a straight line without turning back. But here the body is moving in a straight line and turning back. So that is why, so this is S called the displacement here. So what is the displacement in this case? Initial position is this one and the final position is this. The direction of the displacement is always from initial to the final, right? So the direction of the displacement is always initial to the final, alright? So this is the displacement, initial to the final. If you consider the point where you are throwing the body is as origin, all the upward motion are positive. So we know according to the coordinate axis, so this is the coordinate axis if you feel, this is plus x and this is minus x. So this is plus y and this is minus y, alright. So from the origin, So this is the upward distance is positive and the downward distance is negative. Understand? So from the origin, the displacement is from here to here, right? So displacement is nothing but the height of the tower here. So S is equal to height of the tower, but that height of the tower is negative because displacement is a vector quantity. It will have a direction even, right? That's what minus h, which is equal to, and the body is thrown up, see, u, with initial velocity is thrown up, and t is the time taken by the body to reach the ground, so that is t, alright, plus half into, what is the acceleration? So this is the acceleration. As this concept is motion under gravity, the acceleration is acceleration due to gravity. As the body is thrown up initially, so the acceleration due to gravity is minus g and it is t square. So what I can write now, so this h is equal to, I can say minus h is equal to ut minus half gt square. So from here h is equal to minus ut plus half gt square. My dear students, I have just done the multiplication, right? Both the sides I have done multiplication with the negative sign because I don't want this minus. Now you get finally h is equal to half gt square minus ut, my dear students. Half gt square minus ut. So this is the commonly asked topic of height of the tower. What is that? Height of the tower. It's so simple way of discussing the height of the tower in this way. It's very simple way. Yes or no? Now the questions will be asked in this way, like how the questions will be asked on this topic, and we'll be discussing in the next slide itself. Simple, they'll give everything. They'll give t value, u value, you need to find this h. That's it. T value they will give and u value they will give, you need to find h. By using the simple formula, height of the tower, when the body is projected from the top of the tower upwards, height of the tower is simple to find in this way. Okay? Clear? Now, based on this, there is another application, my dear students, based on this. Same, based on this only. This application is very much interesting than this. Imagine this is the ground. Look at here. So this is the situation, ground. So there is a balloon. Alright, so there is a balloon which is rising from the ground. So we are not throwing it up, which is rising. Means initial velocity, you can say it is 0. Understand? Balloon initially is at rest and it is rising. Okay. So initially the balloon is at rest and it is rising upwards. So rising upwards means definitely it will rise with some acceleration. Yes or no? So the acceleration of the balloon. So what I am writing here is there is a balloon rising upwards with an acceleration a, Now carefully see here. So now the balloon is reached to this point. There is some height, yes or no? See here, the balloon has reached some height from the ground. To reach from here to here, it will take some time. Yes or no? To reach from here to here, it will take some time. Okay, forget about that. Here, there is a body is dropped. A small stone is dropped. Imagine, a small stone is dropped. As the balloon is accelerating, definitely there will be some velocity at this point. As it is moving up, there must be some velocity, right? So here, the body will be moving with some velocity, imagine u, right? At an instant when a stone is dropped, at an instant when a stone is dropped from the balloon, that's an important point. It is rising up with initial velocity called u. At this instant, there is a balloon is dropped, or there is a stone is dropped, and it is rising with an initial velocity. And once again, when this balloon is rising at this instant with initial velocity u, there is a stone is dropped. And remember, when the stone is dropped in this situation, initially the stone will not move downward. It is not a simply freely falling body condition here. As the stone is continued its journey from here to here with the balloon, at this instant, the stone will try to follow the balloon. That's called inertia of motion. Understand? Stone is already there in the balloon. Stone is already there in the balloon and it is rising. It is rising. At this instant, stone will also have the initial velocity u. But when we drop, stone will try to move upwards only with some same initial velocity. Only for some extent, because it is out of the balloon now. Balloon will move and the stone is dropped, right? When the stone is dropped, because of inertia of motion, for some extent it will try to move upwards and its maximum velocity will become 0 at some particular point and it starts coming back here in a time t. What is this time t? T is time taken by the stone. T is what? Time taken by the stone to reach the ground. Right? So the question is, from what height the balloon is dropped? So from what height the stone is dropped? So like this the questions will be asked. So the height from which the stone is dropped is similar to the concept of height of the tower, isn't it? Similar to the concept of height of the tower, my dear children, isn't it? From this height, the stone is dropped. Understand? But it is followed the previous case. It is followed the previous case. What is the previous case? Previous case is the height of the tower. From some height, the body is thrown vertically up. The similar thing is here. Now, what is the height of the tower or height from which the stone is dropped? Simple, direct formula. H is equal to half gt square minus ut. Okay? Direct. Understand? What is this h? Half gt square minus ut. G, acceleration due to gravity, you know. T is time taken by the stone to reach the ground. U is initial velocity of the stone. Understand? Initial velocity of the stone. Again I am telling you, initial velocity of the stone. And T is time taken by the stone to reach the ground. Okay? Clear? And sometimes initial velocity of the stone will not be given. But if you know the acceleration of this, you can find at this particular point what is the velocity of the stone. Right? So velocity of the stone at this point you can find by using equations of motion. Understand? Clear? Velocity of the balloon at any instant, right? In this case, velocity of the balloon at any instant. We can use V is equal to U plus AT formula, where U is 0 because the balloon is starting from rest. So V is equal to A into T. A is what? Acceleration of the balloon. Understand? Acceleration of the balloon. As the balloon will have its own acceleration because we are not considering the acceleration due to gravity in this case, you remember. The body is, we are not throwing the body and we are not dropping the body. We are just keeping the body on the ground and the balloon is moving up. V is equal to AT. And because of its own internal gases, so it is moving. So there is no concept of involvement of acceleration due to gravity over there. Right? So V is equal to AT. This is the formula for velocity of balloon at any instant. So if you know these two things, and you can solve whatever the question based on this. And let's solve two questions based on these topics. Right? So what is the important thing? So this is the important thing. Height of the tower concept is very important. Half gt square minus ut. Okay? So let's solve our two questions related to this model. Alright, my dear children. Let's have a look at the first question. A stone is thrown vertically up from the bridge with a velocity of 3 meters per second. From the bridge with a velocity of 3 meters per second. So let me draw a simple and basic diagram here. So this is the bridge. Okay. Imagine the height of the bridge is h. A stone is thrown up. And this is the situation you know we have already discussed, and a stone will definitely take some displacement and reach to the ground in this way. If it strikes, and this initial velocity is given as 3 meters per second, if it strikes the water on the bridge, see there is a water presence here in a time 2 seconds. What is t? Time taken by the stone to reach the ground, it's 2 seconds. The bridge is at a height of, see height of the bridge we need to find out. H is equal to half gt square minus ut. That's it, direct formula. And we derived this. H is equal to half into 10 into t square is 4 minus u is 3 into 2 because ut is 2. So H is equal to, this is 20 minus 6, it's 14 meter. What is the H value here? 14 meters. Clear? That's it. Is it easy? Remember this formula. Now, a balloon starts rising from rest. I told you these are the two applications very important for the NEET exam. Very important, not only for the NEET exam, for any competitive exam, these are the commonly asked questions. And you might have not studied these in your 9th and 10th standard basics. These are the real first PUC topics, right? Based on your analysis related to the displacement, starting from displacement to the equations of motion. Whatever the analysis you have done so far, that is applicable, that is applied in these applications. Alright, let's see. A balloon starts rising from rest. Carefully see. A balloon starts rising from rest. So this is the ground. A balloon starts rising, means initial velocity of the balloon is 0. So this is the balloon and there is a stone inside. Okay. Moves vertically upwards with an acceleration z by 8 meter per second square. So this is the balloon is moving vertically upwards with an acceleration g by 8 meter per second square. A stone falls from balloon after 8 seconds from start. See, the balloon is moving like this, moving like this. Imagine at this point, right, this is the balloon. So time taken here is 8 seconds. Right? At this instant, a stone is dropped. And I told you, stone is dropped and stone will be moving with whatever the velocity the balloon is moving at this instant. With the same instant, the stone will be moving in the upward direction only. That velocity I am considering as v. And you know how to find that v? I told you already. V is equal to at. Okay. So from where you got that equation? From where you got that? So v is equal to at. From v is equal to u plus at formula only we have got. Okay. So v is equal to at. A is g by 8 and time is 8. So it is g meters per second, right? So what is the velocity here? So g meters per second. Alright. With g meter per second, stone is moving up. Balloon is anyway it is moving with same g meter per second. Stone is also moving up with g meter per second and definitely it's come back. So this is the stone. Stone will be coming back in this way and reaches to the ground in some time t. Okay, so this t and this t, no, you should not get confused. Imagine it's t dash, right? Imagine it is t dash, no confusions. The The t dash is time taken by the balloon from the rest to the point where it is dropping the stone. That's it. Now, find the time taken by the stone to reach the ground. So simple, right? Time taken by the stone to reach the ground. We have the formula h is equal to half gt square minus ut. The t we need to find out. So h is equal to half gt square minus u. What is u? U is initial velocity with which the stone is thrown from the tower. Similar to this case. What is the initial velocity with which the body is thrown from the tower? What is the initial velocity with which the body is thrown from this point? Right? It is similar to the thrown case only. So what is that? G meters per second. So U is G meters per second. Right? So you need to find this T, but this H is unknown here. How to find this? Right? So let's name this equation as 1. How to find this H? That's an important thing. H is what here? H is height of the tower. So height of the tower is this H. This is H. Alright. How to find that H? I have told you clearly, my dear students. The balloon is rising with its own acceleration. There is no acceleration due to concept. Acceleration due to gravity concept is involved here. So I am writing here with respect to the balloon upward motion. Carefully see. With respect to the balloon upward motion, we can use S is equal to ut plus half at square. This is also motion in a straight line, because here balloon is moving with a constant acceleration g by 8 meter per second square. So what is the distance or displacement traveled by the balloon? See, it is moving in a straight line. So what is that? H, which is equal to initial velocity, it is 0, plus half into acceleration is what? G by 8 into t square. What is this t square? It is t dash square. Alright, t dash is from here to here. Time taken by the balloon to move from the ground to this particular height. So let's write it. H is equal to half into g by 8 into t dash square. What is time taken from here to here? It's already given 8 seconds. So this is 8 square, 8 into 8. So 1 8, 8 cancel, and this is 2 4. So H is equal to 4 into G. It's equation 2. So from equation 1 and 2, what I can write? This H, 4G I can substitute here, right? This 4G I can substitute here. Now 4G is equal to half GT square minus GT. Both left hand side and right hand side, let's take G as common. So 4 is equal to T square by 2 minus T. So this I can write it as 8 is equal to T square minus 2T. T square minus 2T minus 8 is equal to 0. Okay. Clear? So if you solve this quadratic equation, you get T value is 4 seconds. What is that? T value is 4 seconds, my dear students. So time taken by this stone to reach the ground is 4 seconds. What is that? 4 seconds. Is this interesting? Is this concept is interesting or not? Definitely, if you are really understanding the topics from the day one, it will be interesting. The most interesting concept of the motion in a straight line. Alright? And some more interesting concepts we'll be learning in this session itself. Let's see. There is a short trick is involved in finding the same time taken by the ball or time taken by this object to reach the ground. If you know H, right? So that's a condition. If you know this H, when H is the known value, there is a short trick to find time taken by the stone to reach the ground. So it is T is equal to root of H by G. T is equal to 2 into root H by G. So T is equal to 2 into root H. What is the H here? H we found somewhere from H is equal to 4G, right? So 4 into G by G. So G cancel. Root 4 is 2. 2 into 2. So what is your time value? It's 4 seconds. Is it similar to our answer? Is it similar to our answer? See. So this is the short trick. This is the short trick, my dear children. T is equal to, right, from where the short trick has come, all the short tricks will be having their own derivations, remember. To save your time, we give some short tricks so that you can easily solve your 45 questions, right? So hardly 50-60 minutes. Otherwise it's impossible. Okay. So this is how the questions will be asked based on the last two applications. And let's have our discussion. Let's continue our discussion with some more 2-3 questions. Let's see one more numerical here. Drops of water falls at regular intervals from roof of a building of height 16 centimeter. Look at here. So this is the ground, okay. Imagine this is the roof of a building. So clearly they mention height is equal to 16 meters from roof to the ground. Water drops of water falls at regular intervals like this. The fifth drop striking the ground, this is the fifth drop striking the ground at the same moment as a first drop striking the ground, right, at the same moment as the fifth drop detaches the floor, detaches the roof. The first drop striking the ground, the first drop striking the ground at the same moment as the fifth drop detaches from the roof. Find the distance between the successive drops. It's so important question and interesting topic here. Simple. There is a roof. You might have observed when there is a problem in our roof on a rainy day, each and every drop will be falling to the ground in a regular interval of time. Yes, sir? We'll keep one small mug or bucket over there. We can see in equal intervals of time, in successive intervals of time gap, the drops will be falling. The same concept is here. Drops of water falls at regular intervals from the roof of a building of height 16 meter. The first drop striking the ground at the same time, at the same moment as the fifth drop is detaches from the roof. Find the distance between the successive drops. Let's concentrate on this diagram. Simple rough diagram. First drop is here, fifth drop here. Where are the other drops? There must be a second drop is here, third drop and fourth drop. Right? First is here, fifth is here. So that means in the middle there are some drops which will be about to fall and strike the ground. Now, S1 is the distance travelled by the first drop. In the same way, S2 is the distance travelled by the second drop. S3 is the distance travelled by third drop. Remember, S4 is the distance travelled by fourth drop. S5 is the distance traveled by fifth drop from the roof. From the roof. Everything is from the roof, my dear children, and no confusions at all. From the roof. Everything. Okay. Now, have a look at the diagram once again. What is the distance traveled by the first body? Which is 16 meters. Yes or no? Understand? Distance traveled by the first is 16 meters. In what time? That's the most important. Right? So as S1 value, so I am writing as S1 value is 16 meters, time taken, let's find out. Time taken to cover this 16 meters, right? We know the formula, T is equal to root 2h by g, which is root 2 into 16 by g. So root 16 is 4, I can say 4 into root 2 by g. 4 into root 2 by g. That's the time taken by the first to reach the ground. Now interesting thing is, every drop will take the same time to reach the ground. Every drop, fifth drop, that may be third drop, or that may be second drop, that may be fourth drop. From here, every drop will take the time taken like this. But we need to concentrate at this instant. At this instant, total time taken is 4 root 2 by g is shared in equal intervals, right? See, this is, at this instant I am writing here, at this instant, this is the easiest way of solving these questions, my dear student. And most of the students will have the confusion on this kind of questions. At this instant, this is the time will be equally shared. Among the other drops, among the other intervals, I can say, among the other intervals. How many time intervals are here? Carefully see, there is one time interval, another time interval, another time interval, another. So 1, 2, 3, 4. Okay. Total time is divided into 4 intervals. So I can say time interval, simple. Time interval between any successive drops. What is the time interval between any successive drops? Is it simple? Let me say that time interval is t dash. So t dash is equal to t by 4. Understand? How many intervals here? Sometimes the question can also be asked, when the first drop is striking the ground, 10th drop is detaching from the roof. In that case also, model is same. So t dash value is this divided by 4, that will be root 2 by g, that's it. Okay. So here time is root 2 by g. Here the time interval is root 2 by g. That means from here to here, the fifth drop to travel from here to here, time taken is root 2 by g. Fifth drop to travel from here to here is 2 into root 2 by g. Fifth drop to reach from here to here, that is 3 into root 2 by g, because this is root 2 by g, it has to travel, root 2 by g it has to travel, and another root 2 by g also it has to travel. And the fifth drop to reach the ground, it should travel 4 times root 2 by g. Yes or no? So root 2 by g, root 2 by g, root 2 by g, and root 2 by g. Okay? Clear? So this is the most important part of the problem. Now, alright, so now almost we have done, right? How? S1 is 16 meters and S2, let's find S2. What is S2? S2 means time taken by the second drop to move from here to here. Understand? So, what is it? Anyway, U is 0. Alright? So, half into G into T dash square. Right? To T dash square, or you can say it is T square. What is T? Time taken by the second drop to move from here to here. So, half into G into T. What is T? From here to here. So, it is root 2 by G, root 2 by G, root 2 by G. How much is the time from here to here? Time taken by the second drop. It's 3 root 2 by g. So t value is what? 3 root 2 by g whole square. Okay. So now what I can say, half into g into half into g into 3 square. It's 9 into 2 by g, because root 2 by g whole square is 2 by g. Yes, 3 similar way, half into g into t square, half into g into what is 3? Third drop, distance travelled by the third drop from the roof, from here to here. It's so simple. It should only travel, it need only to travel 1 root 2 by g here and another root 2 by g here. So from here to here time taken is 2 into root 2 by g, because each interval is root 2 by g. Okay. This interval is root 2 by g, this interval is root 2 by g, this interval is root 2 by g, this interval again. So this is root 2 by g, this is t dash, and another t dash is root 2 by g t dash, and this is also root 2 by g, which is t dash, and this is also root 2 by g, which is t dash, and total time is how much here? From here to here, 4 into root 2 by g. That's what each and every particle or droplet will take time to reach the ground. Alright. And third drop to reach from here to here, it should cover 2 times root 2 by g. So this is 2 times root 2 by g whole square, my dear children. Half into g into 2 square is 4 into 2 by g. S4 half into g into t square, half into g into t square. So fourth drop to reach from here, how much? Only it should travel time root 2 by g only. So t value is root 2 by g. No confusion. Root 2 by g whole square. So half into g into 2 by g. Okay. So from here, S5 is equal to 0 because it is not yet started. Okay. It is just detaching. At this instant we are talking about. That is the most important. At this instant we are talking here. At this instant. Alright. Clear? Now, question. You read once again. What is the question? Find the distance between the successive drops. Distance between the successive drops. This is S1 and this is S2. What is the distance between these two? That's a question. What is that? So is it S1 minus S2? Okay. So in this way, distance between successive drops we need to find out. So what is S1 minus S2, my dear students? S1 is how much here? It's 16 minus S2. So before that, S1 also let me write here. So S1 is how much? Half into g into t square. The first drop, how much time it will take? 4 into root 2 by g S1. Let me write S1 here. S1. Right? So this is square. Half into g into 16 into root 2 by 16 into 2 by g. Okay. So S2 is how much from here? S2 half into g into, look at here, g into 9 into 2 by g. So S2 minus S1 minus S2 is how much? Everything you can take common. Half g into 2 by g. You can take common. See, half into g into 2 by g you can take common from S1. So its remaining is 16 minus here also. Half into g into 2 by g you can take common. So remaining is 9, my dear students. So g by 2 and 2 by g cancel. So S1 minus S2 is equal to 7 meters. S1 minus S2 is 7 meters. S1 minus S2. Same way. S2 minus S3. So you get this one, right? So S2 minus S3. So same way, this is this one. S3 minus S4. Okay. So S3 minus S4. And this one. S4 minus S5. Clear? Now I need your responses. S2 minus S3 is how much? S3 minus S4 is how much? S4 minus S5 is how much? Everything you have. Everything you have here. So you can see everything you have here. Right? You can find them. Alright, my dear children. Clear? Now. So get ready for the assignment. Assignment will be including the last two classes concepts even, because everything we are discussing motion under gravity only. Just get ready for your assignment. All the very best.